According to the National Electrical Code, Romex cables for both sides of a duplex receptacle can be installed in the same wall without being separated. Requirements for duplex receptacle wiring include using a minimum 14 American wire gauge Romex cable. This is the standard wire size for residential duplex receptacles. Connect the black wires together. This creates the hot side of the circuit. Connect the white wires together. This creates the neutral side of the circuit. Connect the bare copper ground wires together. This provides a safety ground path. Specific National Electrical Code Section 300.3. B states that conductors of the same circuit, including grounding conductors, shall be permitted to occupy the same raceway, cable, or enclosure. This includes Romex cables for duplex receptacles. Ensure that the Romex cables are properly secured within the wall using staples or cable ties. Avoid sharp bends or kinks in the cables. Use a cable staple every 12 inches to hold the cables in place. Protect the cables from damage by covering them with a wall plate or other suitable enclosure. By following these guidelines, you can safely install duplex receptacle wiring in the same wall space. Electrical wiring can be dangerous. Always follow the NEC and local codes. If you don't know what you are doing, call a professional. Never work on a live circuit. Always verify the power is off before working on electrical equipment. Use the proper tools for the job. Wear appropriate personal protective equipment. This includes safety glasses, gloves, and insulated tools. Plan your work before you start. Make sure you have all the materials and tools you need. Don't cut corners. If something doesn't seem right, stop and consult a qualified electrician. Always pull permits. All electrical work must have the proper permits. Work must be inspected to ensure it is safe. Keep your work area clean. Remove all debris and materials when you are done. Test your work when you are done. Verify that the circuit is working properly. Electrical circuits are designed to carry a specific amount of current. The amount of current a circuit can safely carry is called its ampacity. The ampacity of a circuit is determined by the size of the wires used in the circuit and the type of insulation on the wires. The National Electrical Code, or NEC, specifies the ampacity of different types of wires and cables. It is important to never overload the circuit. Overloading a circuit can cause the wires to overheat, which can lead to a fire. To avoid overloading a circuit, make sure that the total amount of current being drawn by all of the appliances and devices connected to the circuit does not exceed the ampacity of the circuit. If you are not sure what the ampacity of a circuit is, consult a qualified electrician. Short circuits are a common electrical hazard. A short circuit occurs when electricity flows along an unintended path. This can happen when a wire becomes damaged or when a metal object comes into contact with a live wire. Short circuits can cause a large amount of current to flow through the wires, which can cause them to overheat and start a fire. Ground fault circuit interrupters, or GFCIs, are safety devices that are designed to protect people from electrical shock. GFCIs monitor the flow of current in a circuit. If a GFCI detects that current is flowing along an unintended path, it will quickly shut off the power to the circuit. This can prevent a person from being electrocuted. GFCIs are required in many areas of the home, such as bathrooms, kitchens, and outdoor areas. Arc faults are another type of electrical hazard. An arc fault is an unintentional electrical discharge that occurs when electricity jumps between two conductors. Arc faults can generate a lot of heat, which can ignite nearby flammable materials. Arc fault circuit interrupters, or RFCIs, are safety devices that are designed to protect against arc faults. RFCIs monitor the electrical current in a circuit for characteristics that are indicative of arc faults. If an RFCI detects an arc fault, it will quickly shut off the power to the circuit. This can prevent a fire from starting. RFCIs are now required in many areas of the home, such as bedrooms and living rooms. When working with electrical wiring, it is important to use the correct type of wire for the application. The NEC specifies the types of wires that are permitted to be used in different situations. For example, type NM cable, also known as Romex, is commonly used for wiring in residential buildings. Type UF cable is designed for underground use. Type THHN wire is commonly used in conduit. It is important to use the correct type of wire to ensure that the wiring is safe and meets code requirements. Electrical boxes are used to enclose electrical connections. Electrical boxes protect the connections from damage and prevent people from coming into contact with live wires. Electrical boxes are available in a variety of sizes and shapes. The size of the electrical box you need will depend on the number of wires and devices that will be installed in the box. The NEC specifies the minimum size of electrical boxes that are permitted to be used in different situations. When installing electrical boxes, it is important to make sure that they are properly grounded. Grounding provides a path for electricity to flow back to the source in the event of a fault. This can help to prevent electrical shock. Electrical conduit is a type of tubing that is used to protect electrical wiring. Electrical conduit is typically made of metal or plastic. Conduit protects the wires from damage and prevents them from coming into contact with flammable materials. Conduit is required in many situations, such as when wiring is run outdoors or in damp locations. When installing electrical conduit, it is important to make sure that it is properly grounded. Electrical panels are used to distribute electricity throughout a building. Electrical panels contain circuit breakers or fuses that protect the circuits from overload. Electrical panels should be installed in a dry, accessible location. It is important to label the circuit breakers or fuses so that you can easily identify which circuit they control. When working on electrical panels, it is important to take precautions to avoid electrical shock. Always turn off the power to the panel before working on it. Use insulated tools and wear safety glasses. If you are not comfortable working on electrical panels, consult a qualified electrician. Electrical outlets are used to provide a convenient way to connect electrical devices to the power supply. Electrical outlets are available in a variety of types. The type of outlet you need will depend on the type of device you will be connecting to it. For example, some outlets are designed for use with grounded plugs, while others are designed for use with ungrounded plugs. When installing electrical outlets, it is important to make sure that they are properly grounded. Electrical switches are used to control the flow of electricity to lights and other devices. Electrical switches are available in a variety of types. The type of switch you need will depend on the application. For example, some switches are designed to control a single light, while others are designed to control multiple lights. When installing electrical switches, it is important to make sure that they are properly grounded. Electrical lighting is an important part of any building. Electrical lighting provides illumination for safety and comfort. Electrical lighting is available in a variety of types, including incandescent, fluorescent, and LED lighting. When choosing electrical lighting, it is important to consider the energy efficiency of the lighting. LED lighting is the most energy efficient type of lighting. Electrical appliances are devices that use electricity to perform a function. Electrical appliances are available in a variety of types, including refrigerators, ovens, washing machines, and dryers. When using electrical appliances, it is important to follow the manufacturer's instructions. Overloading electrical circuits can create an unsafe condition, potentially leading to overheating of wires and even fires. It's crucial to understand the load capacity of your circuits and avoid plugging in too many high-power devices into a single circuit. If you're unsure about the load capacity, consult a qualified electrician who can assess your wiring and advise on safe usage. Extension cords are a convenient way to extend the reach of electrical outlets, but they should be used with caution. Avoid overloading extension cords and never use them as a permanent wiring solution. Choose extension cords that are rated for the intended use and length, and inspect them regularly for damage. Damaged extension cords can pose a serious fire hazard. Surge protectors are essential for protecting sensitive electronic devices from voltage spikes. Power surges can damage or destroy electronic equipment, so it's a good idea to use surge protectors for computers, televisions, and other valuable electronics. Choose surge protectors that are rated for the level of protection you need and replace them after a significant surge event. Always call 811 before digging. Massachusetts law requires you to call 811 before you dig. Calling 811 will alert the local utilities to mark the locations of underground utilities on your property. This will help to prevent you from damaging underground utilities when you are digging. If you are planning to dig, call 811 at least 72 hours before you plan to dig. This will give the utilities enough time to mark the locations of the underground utilities on your property. Once the utilities have marked the locations of the underground utilities, you can begin digging safely. Be careful not to damage the underground utilities when you are digging. If you damage an underground utility, you could be held liable for the cost of repairs. In Massachusetts, several codes and regulations govern electrical work to ensure safety and compliance. The Massachusetts Electrical Code, based on the National Electrical Code, provides detailed standards for electrical installations. Local city and town ordinances may also impose additional requirements. Permits are typically required for most electrical work, and inspections are conducted to verify compliance with the code. Following these regulations helps minimize risks and maintain electrical safety in homes and businesses. Continuing education and training are essential for staying up to date with the ever-evolving electrical codes and best practices. Electricians and other electrical professionals are required to complete continuing education courses to maintain their licenses and certifications. These courses cover new technologies, code updates, and safety procedures. Staying informed about the latest advancements in the electrical field allows professionals to provide the best possible service and ensure the safety of electrical installations. Several resources are available for obtaining information about electrical codes and safety. The National Electrical Code is a comprehensive resource that provides detailed standards for electrical installations. The Massachusetts Board of State Examiners of Electricians offers information about licensing requirements and regulations. Local city and town building departments can provide information about local ordinances and permit requirements. Online resources, such as the websites of professional electrical organizations, also offer valuable information and training materials. These resources can help ensure that electrical work is performed safely and in compliance with all applicable codes and regulations. The NEC mandates specific grounding and bonding requirements to ensure electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Bonding connects all metal parts of an electrical system to create a low impedance path for fault current. Proper grounding and bonding are essential for minimizing the risk of electrical shock and fire. ENEC specifies the types of grounding and bonding conductors that are permitted to be used in different situations. It also specifies the methods for connecting grounding and bonding conductors to electrical equipment. Following these requirements is crucial for ensuring the safety of electrical installations. Electrical inspections are an important part of the electrical safety process. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical installations comply with the NEC and local codes. Electrical inspections can help to identify potential hazards and prevent electrical fires and shocks. Most jurisdictions require electrical inspections for new construction, renovations, and repairs. It is important to schedule an electrical inspection whenever you are doing electrical work. The electrical inspector will review the electrical plans and inspect the electrical installation to ensure that it meets all applicable codes and regulations. If the electrical installation does not meet code, the electrical inspector will issue a correction notice. The correction notice will list the items that need to be corrected in order to bring the electrical installation into compliance with the code. It is important to correct all of the items on the correction notice as soon as possible. Once the electrical installation has been corrected, the electrical inspector will conduct a re-inspection to verify that the corrections have been made. If the electrical installation is now in compliance with the code, the electrical inspector will issue a certificate of compliance. The certificate of compliance is proof that the electrical installation has been inspected and approved.